Wow, what a year 2025 was for anyone following artificial general intelligence. I mean, it was a total roller coaster. We went from AGI feeling like it was right around the corner to being told it was decades away again, all in the span of just a few months. So what on earth happened?
So that's the big mystery we're going to unpack. And this wasn't just some public mood swing. Even the top minds at the biggest AI labs were getting serious whiplash. So let's try to make some sense of it all.
All right, section 1. We're calling this the Great AGI Whiplash. First up, let's just look at how wild these mood swings really were, and why everyone, and I mean everyone, was so completely baffled. Okay, so this timeline tells the whole story. It all kicked off in late 2024 when OpenAI dropped its new reasoning models, O1 and O3. The hype just exploded. By January 2025, industry leaders were making these incredibly bold predictions. But then, boom, the cracks started to appear, and by the end of the year, pessimism had totally taken over. I mean, check out this quote from OpenAI's Sam Altman. It perfectly captures that moment of peak hype. And you know what? He wasn't the only one. Leaders at DeepMind and Anthropic were all saying similar things, talking about AGI being just 3 to 5 years out. This wasn't just some cautious optimism. This was them basically saying, we've cracked the code. So what went wrong? So this is where the hype train didn't just slow down. It basically hit a brick wall. It turns out that the incredible performance everyone was seeing, well, it wasn't exactly what it seemed. Okay, this slide is super, super important. You have to understand this part. There are basically 2 ways to make an AI model perform better. You can actually make it smarter, improving its core logic, which is really hard and takes a long time, or you can just give it way more time to think about a problem. This is a trick called inference scaling. Those early models did both, and it was really tough to figure out which one was doing all the heavy lifting.
And it turns out, once analysts really dug in, they realized a massive chunk of those performance gains, like 2/3 of them, came from just giving the models more time to think. This wasn't some repeatable breakthrough. It was a one-time trick, and a very expensive one at that.
I mean, think about it. Going from no thinking time to 1 minute, sure, that's affordable. But then what? Going from 1 minute to 10 minutes or 10 to 100? The cost just explodes. There literally are not enough computer chips on the entire planet to keep scaling this approach up. The hype train had run into a very real, very physical wall, and that wasn't even the only problem. And this analogy just perfectly captures the other big technical problem. The way they were training these new reasoning skills using something called reinforcement learning was just unbelievably inefficient. The AI would make millions and millions of totally garbage attempts to solve a problem, and for each one, all it got back was a simple yes or no. It's like trying to learn calculus, but your teacher just tells you if your final answer is right or wrong, without ever showing you the steps. You're trying to suck this massive amount of intelligence through a tiny, tiny straw. Okay, so beyond those technical limits, another issue started to pop up. This growing gap between what these AIs could do in a perfectly controlled demo and how useful they actually were in the messy, complicated real world. This quote from podcaster Dwarkesh Patel, man, it just hits the nail on the head. The demos were mind-blowing, right? You'd see an AI do some complex software task, and you'd think every company on Earth was about to be totally transformed. But in the real world, productivity wasn't suddenly skyrocketing. So what was the disconnect? Well, there were a few big reasons for this gap. Unlike a new human hire who gets better every day, these AIs would hit a wall, and fast. Researchers also realized that even if you could automate all the coding, AI research is still bottlenecked by a ton of other tasks. And there was this growing fear that all this new AI help wasn't actually speeding up research. It was just helping researchers keep the same pace as the problems themselves got harder. So that's the whole pessimistic case, right? The hype was fake, the tech hit a wall, the real-world impact was disappointing. But hold on, because this is where the story takes a huge turn. While all that public sentiment was souring, a completely different story was playing out behind the scenes. So while everyone was busy arguing about AGI timelines, the underlying engines of AI, its actual economic value and its technical efficiency were just firing on all cylinders. The idea that progress had somehow stalled was just completely, totally wrong. By the end of 2025, the top AI companies were on a path to hit $30 billion of annual revenue. And that's not just a big number, it's almost double what even the most bullish forecasters were predicting at the start of the year. This wasn't a niche product anymore. This was a real mass market phenomenon that people were willing to pay serious money for.
And if you think that revenue number is wild, check this out. The efficiency gains were just staggering. A really difficult reasoning problem that cost OpenAI $4,500 to solve in late 2024 cost just $11 a year later. That is a 400-fold cost reduction. So while the absolute cutting edge was expensive, the stuff just behind it was getting cheaper at a breathtaking speed.
And this, right here, is probably the nail in the coffin for that whole progress is stalled idea. Epoch, a major AI think tank, tracks capabilities across a ton of different benchmarks, and their data shows that the rate of progress didn't just slow down, it actually doubled after April 2024. Behind all the noisy debates and sentiment swings, AI was just relentlessly getting better and more useful. Okay, so what do we do with all this? We've got the hype, the crash, and this powerful engine of progress chugging along in the background. Where does this actually leave us on the real timeline for AGI? You can actually see the impact of this whiplash in the data from the prediction market Metaculus. At the peak of the hype, the collective forecast was for AGI in mid-2031. By the end of the year, that had been pushed out to late 2033. That's a 2.5-year delay getting priced in just a single calendar year. People started thinking things would take a couple years longer. But that's not the whole story. And this quote from Helen Toner, this is what really puts everything into perspective. We've been talking about a delay from, say, 2031 to 2033. But the real story isn't that the timeline got a little bit longer. It's that the entire range of possibilities has gotten squeezed down. What used to be considered a long timeline is now what almost everyone thinks is a plausible medium-term outcome. Think about it. The entire window of what's considered a reasonable debate has shifted. People who just a few years ago were saying AGI was a fantasy for the distant future, decades away, if ever, are now saying, yeah, probably about 10 years away. The pessimists of today sound like the wild optimists of just a few years ago. And that's what brings us to the final and kind of sobering thought here. The whiplash of 2025 taught us that predicting the exact date is incredibly hard. But it also showed us that whether the answer is 2 years or 10 years, the timeline has become profoundly short. 2 years is definitely not enough time to prepare for a technology this transformative. But let's be honest, 10 years isn't exactly comfortable either. So the real question isn't when AGI will arrive anymore. It's, are we ready?